Okay, at this moment we have simple workflow and activity. We know that the workflow actually describes one of the business processes in your application. It means that in most cases it will be some complex flow where we need to make decisions based on some conditions. Often at the particular moment we don't have all required data to make a decision. Thus we need to wait for such data. Moreover, from outside of the workflow, someone would want to retrieve something from the workflow or send something into it. So the next series of videos will be about that. We will build kind of a complex workflow with timeouts, conditionals, signals, queries, and so on. But first things first, and let's start from scratch with a new workflow. Send crypto workflow. Let's assume that we have a flow where a user wants to send some cryptocurrency from one address to another. What the workflow is going to look like? We have a workflow method send crypto that accepts amount, cryptocurrency, and two addresses, from and to. Okay, now the business process. What steps or maybe activities we are going to have here? At first, we store the data of this transaction in the storage, or let's say in the database. To be explicit, we can call this transaction database transaction. Then we need to create or sign a crypto transaction on blockchain node. Once the transaction is signed, it needs to be broadcasted on node. Also, before broadcasting, we save database hash in our database. Then, after being broadcasted, transaction needs to be confirmed on the blockchain. After the transaction is confirmed, we mark it as completed in our storage. These steps can be separated into three activities. The first one represents the storage in our system. Here we track information about the transaction. The second activity can communicate with blockchain nodes. It can sign and broadcast. And the last one is responsible for retrieving information from blockchain explorers about broadcasted transaction. So this is our flow, and let's go ahead and implement it. And we can start with the first activity. Let's call it transaction storage activity. To start, let's implement the first method, init transaction, that accepts all the same arguments as the workflow does. Now we need to return a transaction ID from here. Instead of object, let's return a plain string here. Okay, we can start implementing the workflow now. Let's add a constructor to our workflow. And here we instantiate our first activity that stores transaction data in our database. We provide the class, activity options, and let's fix type hint here. It is actually an instance of activity proxy that proxies all calls of transaction storage activity. Okay, now the workflow method. At first we instantiate the transaction. Don't forget yield, because we need this call to be blocking. We need to wait for an ID. Okay, the step is done. Then we sign a crypto transaction. This is a new activity. Go ahead and create it. Blockchain node activity. method sign, it accepts again all our arguments and will return a transaction hash. Okay, in the workflow in the constructor, we instantiate a new activity. Provide class, options, declare the property, and update the type hint. And implement the next sign crypto transaction step. Again, we use yield to wait for a hash. Now, having hash and transaction ID, we need to update data in the database. We move back to transaction storage activity and add a new method to update transaction and mark it as signed. It accepts a transaction ID and a hash. Add annotation and call this method in the workflow. Now, okay, this step is done. The next one is to broadcast a transaction and then mark it as broadcasted in our storage. So let's update our activities. The first one is storage. Here we add method markBroadcasted that accepts transaction ID. Then blockchain node activity with method broadcast that accepts transaction hash. Now the workflow. We broadcast the transaction. At this point, we need to wait for it. Once transaction is broadcasted, we update it in the storage. And the last step, where we check our transaction on the blockchain. Here we will use a new activity. Let's call it Blockchain Explorer activity. It has method check confirmations that accepts a hash and returns a number of confirmations. Or it may return null if the transaction is not found on the blockchain. For simplicity, let's return 1 here. Now go back to the workflow. First of all, we instantiate a new activity. As always, we provide a class, activity options, we declare the property with the correct type hint. Then we get confirmations from Blockchain Explorer. One notice here that it is not enough to get this data just once. There may be no transaction in the blockchain yet. For example, the blockchain node wasn't too fast to broadcast it to other nodes. Also, the transaction may exist, but it can have not enough confirmations. Thus, in this case, we need to continuously check transaction on Explorer. How can we implement it in the workflow? We can use do-while loop, for example. And we check that we have received confirmations number and that this number is greater than 0. Okay, if we are out of this loop, it means that the transaction was found on the blockchain and it is confirmed. In this case, we need to mark this transaction in the storage as completed. So go ahead and add this method to our activity. In the workflow, we call it. Let's also return some string from the workflow saying that the transaction with our hash was completed. That's it, our workflow is done. Let's try it. Open our command, change the name, change the workflow class, and let's add some random arguments. I think we are ready, so let's run our workflow. Wait for some seconds, and it works. We can look through all the steps in Temporal UI. With our local setup, it is available on port 8088. Here is our workflow, and you can see all the steps here. All our activity calls are listed. So this was an example of a real-world workflow. Later you will see how we can improve it.